very good evening to all our viewers and welcome to yet another physics talk. Today we'll learn about research interests in the field of atmospheric physics. And we have with us a former president of the Physics Society, Mr. Vasura Jayaweera. To formally begin today's proceedings, allow me to invite the Secretary of the Physics Society, Rishi Ranshikliyanage, to deliver the welcome address.
Thank you, Udita. Respected lecturers, our guest of honor, Mr. Vasura Jayaweera, President and committee members of the Physics Society, University of Colombo, and all the participants. Good evening to you all. I am Rishi Ranshikliyanage, and as the Secretary of the Physics Society, University of Colombo, I would like to welcome you all to this session of physics talk on research interests in the field of atmospheric physics. First of all, I would like to welcome our guest here today, Mr. Vasura Jayaweera. He is a former president of Physics Society, an honors graduate of physics from University of Colombo, and is currently completing his Ph.D. on atmospheric physics at the Western University, Canada. Then I would like to welcome Professor Baludaya, the senior treasurer of the Physics Society, along with all the lecturers and demonstrators who have taken time off their schedules to join with us here today. Next, I would like to welcome Mr. Eran Kavinda, president of Physics Society, University of Colombo, along with all the committee members of the society. Finally, I would like to welcome all the participants who have joined with us here today. Last time we met, we, the Physics Society of University of Colombo, promised you to bring a series of webinars on different fields of physics. Keeping that promise, we bring you this session of the Physics Talk series on atmospheric physics. Our hope is to encourage more people to pursue careers in sciences, especially physics. We have planned more webinars in this matter, and we hope that you will stay tuned with us. Welcoming you all once again, I would like to call upon Udita to carry out the rest of the session. Thank you.
Thank you, Riz. Now, allow me to introduce to you Mr. Vasura Jayaweera. Just like Riz said, he is a graduate with an honors degree in physics from University of Colombo. He is a former president of the Physics Society, and now he is completing his PhD in the Western University in Canada. Today, to talk to us about research interests in the field of atmospheric physics, I invite Mr. Vasura Jayaweera. The screen is yours.
Thank you, Udita, and I would like to thank the Physics Society for inviting me and having me. It's a great pleasure to be a part of this Physics Talk series. So I will share my screen. So you can see my screen, right?
Yes, we can.
Okay, fine. So in this talk, I will briefly talk about the atmospheric research field and also a little bit about the research projects that my research group is involved with. And I will also talk a little bit about higher studies opportunities in Canada. So if you're interested in applying for graduate studies, I believe that you have to make two very important decisions. And one of those decisions would be to choose a research field that you're gonna do your PhD in. And the other decision would be to choose a country that you're gonna pursue higher studies. So in this talk, I will briefly talk about what I considered when I made those decisions as well. So as I mentioned earlier, my research field is actually atmospheric physics. So atmospheric physics is basically the study of Earth's atmosphere and also the atmosphere of other planets. So for this talk, I will only talk about the atmosphere of Earth because that's the most studied atmosphere, and that's what my research group is interested in. So as atmospheric physicists, we use a lot of mathematical modeling and physical models to study and understand Earth atmosphere as well as its weather systems. So this diagram here is a small diagram of the atmosphere, our Earth's atmosphere. So you can see there are several layers. So these are the main layers of our atmosphere, and the innermost layer is the troposphere, and the outermost one is the exosphere. So in between there are several other layers. So the troposphere, it starts at the Earth's surface and it extends to around 8 to 15 kilometers high. And this is a very, I think this is the most important layer in our atmosphere, because all the weather activities happen inside this region. And then starts the stratosphere, which actually starts just above the troposphere, and it extends for around another 15 kilometers. So this is another very important layer in our atmosphere, because the ozone layer is actually found in this layer. So most of the atmospheric studies are done in these two layers. So I will talk about these studies as well. So as I mentioned earlier, if you're pursuing higher studies, you have to eventually choose a research field. And here I have mentioned some of the factors that I believe are the most important factors that you should consider when you're choosing a research field. So I believe that the most important factor that you should consider when choosing a research field is your interest, because a PhD program is something that will take around 5 to 6 years to complete, and it's very important that you're working on a field that you have an interest on, because if you don't have an interest on the field that you're working on, you won't have a lot of motivation to actually continue your studies and finish your PhD. So because of that, I think the most important factor when choosing a research field is your actual interest. And then the next 3 points, I think they're equally important as the rest. So one of the other points that I considered was the skills that you will actually learn through your research field. So when it comes to my research field, which is atmospheric physics, it is a multidisciplinary research field. It involves a lot of experimental physics, which involves application of remote sensing, and it involves a lot of theoretical physics as well, such areas such as optics, statistical physics, and areas such as statistics. And then there's the programming side. So atmospheric physics, it involves a lot of programming. We build a lot of models and we do a lot of data analysis tasks. So because of this, we get a really good exposure to computer programming. And as all of you know, computer programming is something that it's a really important skill right now. Everybody should have a good understanding and good background in programming in this research area and in our field of physics. And if you can incorporate subject areas such as machine learning into your research, then you can really widen your knowledge about computer programming. So these were the reasons why I chose atmospheric physics in terms of skills. And then you have to consider the demand for your field. So when it comes to atmospheric physics, you know that right now Earth's atmosphere is going through a lot of changes, and most of these changes are due to our own activities. So climate change and global warming has become global issues of the modern world, and because of this, the demand for more research in this area is increasing every day. So it is safe to say that the demand for atmospheric physicists is increasing daily. So, and finally, I included this point, which is the big picture. So what I mean by big picture is how you feel about about the work that you are doing as a physicist. So for me, working on the atmospheric field, I feel that I'm a small part of this big community of researchers that are trying to study and understand and find solutions to global issues such as climate change and global warming. So it feels good to be a part of this community. So again, every research field in physics is equally important. They do a lot of good work, and because of these important findings, our life becomes easy every day. So it is really important that you see the big picture of the work that you're doing. So I believe these are the 4 points that I believe are the most important when you're choosing a research field. So next I will talk a little bit about the projects that my research group is involved with. So my research group is a LiDAR research group. So LiDAR stands for light detection and ranging. I'm pretty sure that you all have heard about radar. So radar stands for radio detection and ranging. So so LiDAR and radar, they're very similar, but the only difference is in radar we use radio waves, and in LiDARs we'll use light waves. So LiDAR is one of the backbones of atmospheric research fields, and it deals with the profiling of the atmosphere. So One of the main reasons for the wide usage of LiDARs is that due to their high spatial and temporal resolution, which means they have the potential of covering the height ranges from ground to more than 100 kilometers of altitude. So scientists have been using LiDARs to study the atmosphere for many decades. So it's a very powerful tool. So I have listed here some of the big research projects that have been done using LiDARs and that are currently being done using LiDARs. So one is the stratospheric ozone depletion, which is a huge problem we are facing right now, and it is documented globally using LiDARs. And meteorological phenomena such as hurricanes are also studied and predicted using LiDARs. And LiDARs also contributes to our knowledge of the climatic effects of aerosols, volcanic eruptions, desert dust, and forest fire smokes. So as you can see, LiDAR plays a very major role in atmospheric studies, and it has a lot of applications. So, so one of the projects that we are involved in right now is the RALMO project. So RALMO stands for Raman LiDAR for meteorological observation. So it's a kind of LiDAR called the Raman LiDAR. So this is a LiDAR that is operated by the Federal Office of Meteorology and Climatology in Switzerland, short for METEOSWISS. So this diagram is a picture of the Raman LiDAR at METEOSWISS. So this is one of the most powerful LiDARs in the world. It's a fully automated LiDAR, and it's operating nearly continuously since 2008. So as I said, this is a very powerful LiDAR, and it's a very complicated instrument. So what it basically does is it sends a powerful laser beam up towards the atmosphere, and this laser beam will hit different particles in the atmosphere, and it will backscatter. And the scattering is the scattering that happens is Raman scattering. That's why it's called Raman LiDAR. So Raman scattering corresponds to inelastic collisions of electromagnetic waves with particles in the atmosphere. So this backscattered signal is then collected through the telescope mirrors, and then they are used to measure different parameters of the atmosphere. So the project that we're doing right now with METEOSWISS involves the usage of Raman LiDAR for high resolution vertical profiling of water vapor within the troposphere. So water vapor is a very important parameter because water vapor plays a fundamental role in the radiative energy transfer, the hydrological cycle, and the atmospheric chemistry that determines the weather system and climate of our planet. And also because water vapor has a strong absorption and emission bands, especially in the infrared range, and because of its abundance, water vapor is the most significant greenhouse gas, and in this sense it's the most important in establishing our Earth's climate. And the water vapor is also responsible for the water vapor evaporation condensation cycle, which is an important mechanism for transferring heat energy from Earth's surface to its atmosphere and moving heat around the Earth. So it's really important to study water vapor when it comes to atmospheric studies. The other project that we are involved with is the micropulsar LiDAR project. So again, this is another kind of LiDAR, just like the Raman LiDAR. So it's here you can see a diagram of a mini micropulsar LiDAR. So mini MPLs, they're smaller than Raman LiDARs, and they are small LiDARs with low power, and they use elastic backscattering in their process. So this instrument is a ground-based optical remote sensing system, and it's mainly used to detect clouds and aerosols in real time. So next, I will talk a little bit about NASA's MPL network. So the NASA's MPL network is a network of MPLs spanned across the globe, covering all the continents of the world except for Australia. And the data collected through these micropulsar LiDARs placed at different locations around the globe will collect data, and this data then flows back to NASA. So this micropulsar LiDAR network is actually maintained and handled by NASA. So if you look at the map, you can see where these LiDARs are placed across the world, and you can see they are located at different areas of the world, and some of these areas are very remote places, such as the South Pole and North Pole. So if you look at the Canada region, where about United States, you can see that there are no micropulsar LiDARs in the Canada region. So this is because up until now, Canada has not been part of this network, but my research group along with other research groups are now going to set up an MPL network across Canada and then join NASA's MPL network. So this is one of the MPLs of the NASA's micropulsar LiDAR network. So this is actually a MPL that is actually located in Namibia. So Namibia is a country in southern Africa. So as I mentioned, most of these stations are like located around very rural areas. So this is actually, I think, located in the deserts of Namibia. So in this diagram you can clearly see the laser beam that is pointing upwards towards the atmosphere. But in real life, you won't really see this laser beam unless you stand really close to the MPL, since this is a long exposure photograph. That's why you can clearly see the laser beam. So as I mentioned, we are going to start an MPL network across Canada. So this is a very exciting new project. So our plan is actually to set up 5 micropulsar LiDARs across Canada. So right now we have already placed 2 micropulsar LiDARs, one in London, where my university is, and the other one we have placed in Halifax in Nova Scotia. So we have 3 more micropulsar LiDARs to place, and 2 of them we are going to place in Toronto and Sherbrooke. These are cities. And the final one we are going to place in the high Canadian Arctic in the North Pole. So that is, you can see in the diagram, the distance between these LiDARs. So we're going to place the final one in the Pearl. So Pearl is in Eureka. It's a research station in the North Pole. So yeah, as I mentioned, our final LiDAR, we're going to place that in the polar environment, North Pole. So we're going to place that in the Pearl. Pearl stands for Polar Environment Atmospheric Research Laboratory. So this is a part of the Canadian Network for Detection of Atmospheric Change, and it's located in Eureka. So Eureka is a research base in the North Pole. So these are highly remote places that cannot be easily accessed, and they have harsh weather conditions. So temperature here goes for around -6 degrees Celsius. So during the past, a lot of students in my research group had the opportunity to actually work in this research lab. So it has been a great experience for them. So the MPL network that we are going to set up in Canada has several scientific objectives, and here I have listed down the main scientific objectives of the MPL network in Canada. So one of our main objectives is to determine and understand the effects of particulates and clouds on ozone variations. And another scientific objective is to measure and improve our ability to track forest fires. So forest fires is a huge problem right now. So as you all know, last year the world experienced 2 major forest fires, one in Australia and one in the Amazon rainforest in South America. So with a good MPL network, we can improve our ability to track these forest fires and better prepare for them. And we can also track volcanic ash and pollutions that will improve our understanding about aerosols in the atmosphere. And our final scientific goal is to determine and understand the effects of particulates on the formation of cloud and fog. So each of these scientific goals are equally important. So depending on where the MPL is set up, they will measure different kinds of different stuff. So the one that we're going to place in the Arctic, it will actually measure ozone variations, and the one that we are placing in the cities, they will measure volcanic ash and track forest fire, and the one that we are placing in Halifax, that's going to measure cloud and fog. So if you're interested about more details about this project, you can actually follow the MPLNet site, which is maintained by NASA. So I have here given here the website for that. So there are a lot of details about the data and what kind of work that we're doing, in this network. So that's what I wanted to talk about, the research projects that we are working on right now. So that was a very brief overview. I did not want to go into a lot of technical details. So as I mentioned in the beginning, you have to make two big decisions when you're planning to do your higher studies. So one of those decisions is actually choosing which country you're going to pursue your higher studies. So next I will briefly talk about the graduate studies in Canada and some similarities and differences compared to US. So I study at Western University in Canada. So this is a picture of my university. So it's located in Southern Ontario in Canada, closer to the US border. And this is another picture of the Physics and Astronomy department where I work at Western University. So when it comes to graduate studies in Canada, Canada and US have very similar programs, except for a few differences. So in Canada, generally the Ph.D. program runs for around 5 to 6 years, and all the major research fields such as experimental and theoretical condensed matter physics, medical physics, planetary sciences, astronomy, astrophysics, particle physics, all these major research fields are available in all Canadian universities. And almost all the students who receive admission will receive full scholarships, and the funding will come in the form of graduate teaching assistantships and graduate research assistantships. And one of the main differences compared to US is that the requirements when applying for graduate schools, they're a bit different in Canada. So just like any other country, you have to actually do an English language proficiency test. So IELTS is the required one, but many universities in Canada will accept TOEFL results as well. In Canadian universities, most of the programs, they do not require GRE Physics as well as GRE General. But my opinion is that you should actually do GRE Physics, because if you have a good score, that will actually strengthen your application. So this is something that I can personally relate to, because when I had my interview with my professor here at Western, just 2 days prior to my interview, I received my GRE Physics score. And I think that was a huge factor that helped me to actually secure a position in my research group. So because of that, I think it's really important that you do GRE Physics, even though it's not a requirement. If you have a really good score, it will really strengthen your application. So another difference in the application procedure is that almost all students applying for graduate studies in Canada will actually first contact a professor and write to a professor asking for any opportunities in their research groups. And this will follow usually with an interview. And if the professor is satisfied with your qualifications, he will accept you into his group. And after that, only you apply for admission. So with this procedure, you have to actually decide the research field prior to applying, but always you can change your field later during the first couple of years of your graduate studies. So I think it's a bit different in USA. I think it's the other way around. You first actually apply for admission and then you later determine the research field, I think. But even in USA, I know a lot of people who have actually, first talked to professors and secured positions in their research groups. So that's what I wanted to talk about, graduate studies opportunities in Canada. So next I will finally talk briefly about life in Canada. So Canada is, as you all know, one of the best countries in the world to live in. It's a very peaceful country with excellent education system and healthcare system. So currently Canada is ranked as the most educated country in the world. And when it comes to quality of life, again, Canada is ranked as the country with the highest quality of life in the world. And if that doesn't impress you, Canada is considered as one of the most beautiful countries in the world. It is the second largest country in the world, and it's surrounded by 3 oceans, the Pacific from the west, the Atlantic from the east, and the Arctic Ocean from the north. And because of this, it has given rise to a wide variety of beautiful landscape. So this is actually a picture of the Banff National Park in Alberta, Rockies Mountain. It's the oldest national park in Canada, and it's a very popular tourist destination. It is home to some beautiful glacial lakes, which have these beautiful light blue color water bodies. So I live in the province of Ontario. That's where Western University is. So I live closer to the US border in Southern Ontario. So Ontario is a very popular tourist destination as well. So I'm pretty sure that you all have heard about Niagara Falls. It's one of the most popular destinations in Ontario. Millions of people visit this place every year. Niagara Falls is actually a 2-hour drive from where I live. And also Ontario is located around the Great Lakes area. So Great Lakes are 5 interconnected freshwater lakes, and they are the biggest lakes on the planet. And to give you an idea about the size of these lakes, so Lake Superior, which is the biggest lake out of the 5 lakes, it's actually bigger than Sri Lanka. So because of these lakes, it has given rise to some beautiful landscapes, and there are some beautiful travel destinations in the province of Ontario. So these are some beautiful places in Ontario. So this is a picture of the Bruce Peninsula National Park. Again, a national park that is close to where I live. It's around a 4-hour drive from where I live. And this is another picture of Algonquin Provincial Park, again, one of the wilderness areas in Canada. And this is a picture of the Boreal Forest of Canada, which is the largest forest in the world. It's actually bigger than the Amazon rainforest. So most of Canada is covered by forests and these lakes. So there are like a lot of places in Canada that you can visit. There are like more than 1,000 national parks plus provincial parks in Canada. Even one lifetime is not enough to actually explore these beautiful places. So here are some more pictures of several places that I visited. So Canada, like many other Western countries, have seasons. So in Canada, we go through the fall, the winter, the spring, and the summer. This is a picture that I took during last fall. So fall is the season where trees change their color and shed their leaves. Personally, this is my favorite season of the year. So it's very beautiful. There's a lot of transformation happening in the environment around you. And then comes the summer, which is the hottest time period of the year here in Canada. So a lot of people spend a lot of their time outdoors during summer. And this is another picture that I took of the Lake Huron, which is the 3rd largest lake in the world. So you can see that beautiful colors of the water here, so these lakes are pretty beautiful. And they have crystal clear waters, and in some places of these lakes you can actually see old shipwrecks that happened hundreds of years ago. So these are really exciting places to visit. And then comes winter. Canada is known for cold and long winters, but again this depends on which part of Canada you are living in. Some parts of Canada does not even get any snowfall. So places like British Columbia, like Vancouver Islands, they don't really get any snowfall. They are comparatively warm. But I live in Southern Ontario. Southern Ontario get a considerable amount of snowfall, and sometimes it hits around minus 20 degrees Celsius. But if you go to more northern areas, you will experience some harsh winters. With low temperatures. So this is again a picture that I took in Algonquin Provincial Park, which is more towards the northern side of Ontario. So they experience harsh winters. So this is a picture that I took after a snowstorm. So even though you can't see it, the snow here is pretty deep. And this is the final picture is actually a picture of Northern Lights. So Canada is one of the best places in the world to see Northern Lights. And it's if you go to the northern areas, you can get some pretty amazing views of the Northern Lights in Canada. So all these pictures I included to show you how you can spend your life here in Canada. It's a great place to live in, and also a great place to pursue higher studies. So with that, I will conclude my talk. So it's I only did a very brief talk. I didn't go into a lot of technical details. I just wanted to give a very brief idea about what projects that we are doing under atmospheric physics, and what is it like to do higher studies in Canada, and what is it like to live in Canada. So thank you very much for listening to my talk. So if you have any questions, I'm more than happy to answer them.
Thanks a lot to Mr. Vasura Jayaweera for that wonderful presentation. And if our viewers were not captivated by the first part, which was about atmospheric physics, I'm pretty sure they were taken away breathless by the beauty of the country that you are in. So I'm pretty sure there'll be quite a few people waiting to jump the ship to Canada to do their higher studies. So like Mr. Vasura said, you're free to send in your questions. You can raise your hand, you can unmute yourself, you can type it in the chat, and we'll make sure that your question gets to Mr. Vasura. So until the questions start trickling in, I have a few questions of my own. Why don't we dial back the time to where it all began? Why don't we talk about your school days? What were you like in school and how did you spend your school time?
Well, I actually went to Anand College in Colombo. So I was there for the whole 13 years. So, well, school days, I wouldn't say that I've always been good at studies during school periods. So there were like a lot of up and downs. But I was always interested in science, particularly in math subjects. So during my school life, I was also involved in sports activities. So I did athletics, I did some chess, and I also participated in activities like in societies like in track club. So that's how I spent my school life. I wouldn't say I was very much into a lot of studies when I was in school, but you know, I think I balanced everything out in the end. So it was all good, yeah.
So for those of you, if there are any school kids here who are not quite well in studies, they still have hope.
Yes, definitely.
So you said that you were inclined towards science and maths in your school days. What led you towards science? What was that initial spark that took you to the field of science?
Well, I think I was very interested in scientific facts, like from a very early age. I remember having several books which are like intended towards like children, like when I was in like grade 1 or grade 2. So these books, they have like cool scientific facts about little different kind of scientific stuff, like about auroras, about I don't know, like the history of the planet and stuff like that. So I think I was like motivated by those stuff. Like I always had the ambition to actually become a scientist, but I never knew I was going to be a physicist. I didn't even know about physics until I think I came to like my O-level. So then after when I started doing advanced level, at first I actually wanted to become a chemist, but after I finished my halfway through my advanced level, I kind of realized my interest was not in chemistry but like in physics. So after that, I thought I'm gonna pursue a career in physics, and so I think my spark point was, I think like those little scientific facts, those interesting scientific facts. That's what kind of gave me the motivation to like study these stuff. The natural curiosity to understand how these processes work, how the world around us works. So yeah.
Yes, that's a great motivation to the younger generation and for those who are willing to get into the field of science. So after your A-levels, you joined the University of Colombo. You selected to a special degree in physics, and you did quite well with your studies. What was your uni life like? How did you enjoy your uni life, and what are the memories that you had?
Well, university life was really good. I'm really happy that I had a really amazing university life. I still consider that was the best period of my life, those 4 years. And I was very fortunate to get involved with a lot of extracurricular activities. So I had a lot of good memories when it comes to extracurricular activities. So I think I spent a lot of time in my 4 years doing extracurricular activities rather than studies. But I managed to balance everything out. So yes, undergrad life has been was really good. Was really memorable and enjoyable. Yeah, so it was really good. Yeah.
Even I remember you playing guitar at quite a few shows. Yes.
Yeah, I was involved in some music stuff as well. So yeah, it was really good. I was involved with some other societies as well.
Yes.
And I was involved with physics as well. So it was great to work with all those people. A lot of experiences. Yeah.
Wonderful. So we do have a question. Unfortunately, the name reads R, so I can't figure out what your name is. The question is, how long will it take to complete higher studies, and what are the opportunities?
So as I mentioned, if you're doing a PhD, it will take around 5 to 6 years. If you're doing a master's, it will take around 1 or 2 years. So I think most people, when they say higher studies, they will actually go for a PhD. So that will usually take around 5-6 years. It doesn't actually depend on which country you are doing your PhD. Almost all the countries, the PhD will actually take around 5 to 6 years. So in terms of opportunities, it actually again depends on which research field that you are in. So I mentioned this previously. So it's really important that you choose a research field that will enable you to get a lot of skills, because you can either go to the academic side or the industrial side. So if you're going for industry, it's really important that you have a lot of skills, a lot of programming skills. So this is something that I think a lot of Sri Lankan students lack, and I myself, I'm not still good at programming, but since I'm in a research field that involves a lot of programming, I'm now learning a lot of programming. And one of the best advices that I can give you is try to learn machine learning. That is very important. Like when I came here, I realized how important it is. So we don't have a lot of knowledge in machine learning, but artificial intelligence is something that's gonna really develop, and it's developing, and it's still used, and it's now used by many industries. They are slowly turning everything into artificial intelligence. So that is one of the best advices I can give you. Like try to incorporate machine learning into your studies. So that will be really important in choosing a career path. Yeah.
Yes, wonderful. I hope that answered your question. We have another one from Manidu Miraj that goes like, what are the advantages by doing atmospheric physics?
Well, I hope he's meaning advantages for your career path, I think.
Manidu,
So again,
you can clarify if that's the question, but yes, we'll take it as that for now.
Yeah. So as I mentioned previously, atmospheric physics is a very multidisciplinary research field. It involves a lot of theoretical physics. It involves a lot of experimental physics, and like my research field, it involves a lot of optics, statistical physics, and I do a lot of modeling using statistics. So I have never done actually statistics even when I was doing my undergrad studies. So I have to learn all this stuff again, like all this stuff from the beginning. So, and then again, then there's the computer programming part. So because of this, you're exposed to a lot of different fields, a lot of subject areas. So when you're choosing a career path, having a lot of skills, having a lot of knowledge in all those wide areas is going to be an advantage. So I think that's one of the biggest advantages of doing atmospheric physics. And again, as I mentioned, the demand for atmospheric physics is always increasing because of the things happening to our atmosphere. So because of that, I think atmospheric physics is a very demanding field with a lot of opportunities.
Wonderful. So we have another question that comes from Vasura Jayaweera, and the question is, what was the biggest challenge you had to face academically during your time as an undergraduate?
Well, the biggest challenge I think was managing my time. As I mentioned, I was involved with a lot of extracurricular activities. So every year, like for around 6-7 months, I'm always like occupied with extracurricular activities. So I had very little time to do studies. But so that was the biggest challenge when it came to studies. But I did a lot of self-studies. So I think it's a very important skill that you must learn. Doing a lot of self-studies. There are a lot of materials in the internet. It's a very powerful tool. So doing self-studies really improves your knowledge. And if you can teach other people what you learned, that also really helps you to understand what you learned. So actually, that was the biggest challenge I faced. Like managing my time. Yeah.
Okay, I have a question via direct message, and I'm wondering whether it's ethical to ask it. So if it's not ethical, you cannot answer it. How much do you get paid as a demonstrator in the university, and how much do we need to live in Canada for a month?
Yeah, again, this actually depends on the country that you're living in. So US, I know that they pay a little bit more than Canada. So in Canada, the salaries actually range from $1,000 to $2,000. So it again depends on which faculty you're working, and it depends on your professor. So, but again, these salaries are enough to live in whichever place that you're living in, because they calculate these salaries taking into account of the cost of living and all those factors. So it's enough to actually live a good life. These salaries they're paid in the form of they come in the form of like graduate teaching assistantships and graduate research assistantships. So it's kind of a mixture. So for example, at Western University, during the fall term and the winter terms, all graduates are required to do hold teaching assistantships. So for those 2 terms, we get our salaries as GTAs, and but we get a GRA portion as well. But during the summer, we don't have any teaching assistantship duties, because all the undergrad students they have vacation during the summer. That's when we switch to research assistantship. So then our salary comes in the form of that. So that's how it works in Canada, and that's how it works in other countries as well. But again, salary that you receive is actually enough to live in the area that you're actually living in. So in some towns you will see that the salary is higher, because some cities like in Toronto, the cost of living is high. So they always take that into account when they are calculating a salary. Yeah.
Wonderful. KB Prihan is asking us what programming languages are recommended.
My research group actually mainly use MATLAB. So I think even when you're doing undergrad studies at University of Colombo, I think the programming language that you're most working with will be MATLAB. And another very important programming language would be Python, because as I said, machine learning is something that you should definitely learn, and a lot of machine learning stuff is done using Python. There are a lot of materials to learn machine learning using Python. So I think Python is equally important as MATLAB. So those are the 2 programming languages that I can recommend. So, and out of those programs, I really recommend learning Python. It's a very easy language to learn as well. But I think we are not that much exposed to Python, especially if you do a physics special degree. So, but again, I said there are like a lot of resources in the internet that you can follow to learn these languages. So yeah, Python and MATLAB would be my recommendation. Yeah.
Yes, so Python and MATLAB it is. Nisar Bimsara is asking whether it's good to do an MSc before doing your PhD.
Well, actually, when it comes to graduate studies, so I told you, graduate studies, they will take around 5 to 6 years. So most of these programs, they actually have a hidden master's program. So actually, the first 2 years of your graduate study program, you will be actually doing a PhD comprehensive exam. That is getting selected to the PhD program. So you have to write an exam, and if you have good marks, you get selected to PhD. So these first 2 years actually is like a master's program. So in some universities, you have the option to actually convert those first 2 years into a master's program. So that's what I did. So my program, again, it was 5 to 6 years. So I did a 1 year master's. So that's actually a part of the PhD program, but I was able to get a separate master's, and the rest of the years will be my PhD program. So because of that, there is actually a hidden master's program actually in the PhD program. But again, depending on in your university and your program, you have the option to actually obtain a separate master's. So it's always good to do a master's, some universities you can actually get straight into the PhD if you have already done a master's. But most of these countries, they really require a master's in their own country, and so that's how it works here. So yeah, so it's good if you can do a master's, but most of these programs, they have a hidden master's in these graduate programs. So yeah.
Yes, we encourage everyone to keep their questions coming. We have Manind Miraj with another question, which goes like, globally, what are the paths in the field of physics?
So this is a very broad question. So again, I think there are like two main career options that you could choose. You can either go to the academic field or you can go to the industry. So if you are going for the academic field, you have to like get some certain qualifications. You have to do a couple of postdocs. If you are going to the industry, that's another different path. So I think there are a lot of opportunities in both fields, but I think it's generally a bit difficult to get into the academic field. There's a lot of competition, and so like if you look at our past graduates, I think a lot of people are working in all sorts of fields. There are NASA scientists, there are people working on the materials sciences field. There are like atmospheric physicists like me. We have graduates who are working in weather, like modeling of weather systems, modeling of climate, and studies like that. So yeah, so there are like a lot of opportunities. You can't really pinpoint like one particular direction. So again, it really depends on your preference, what you're planning to. Are you gonna go into the academic field, or are you going to go into the industry? And again, industry, there are like a lot of opportunities. Some opportunities could not be directly related to physics. If you have like a lot of skills, again, like related to programming, you can easily go into these fields. So yeah, so if you're doing physics, you really have a lot of opportunities. You have a broad range of areas that you can really go for. Yeah.
Okay, so Kisaru Ashan is asking, if we're hoping to come back to Sri Lanka after doing, do you think it's worth it to do higher studies?
Well, actually, I wouldn't say it's not worth it if you're coming back to Sri Lanka, but because higher studies is about doing research work. You get a lot of experience by following a PhD. So if you're coming back to Sri Lanka, it again depends what you're going to do in Sri Lanka. So most people I know, they join the staff. So if you're joining the staff, you have to have a PhD. So I don't think it's a waste doing higher studies if you're coming to Sri Lanka. So it's all about improving your skills, improving your research skills, improving yourself as a physicist. So it doesn't really matter where you're actually going to stay.
There's a follow-up message on the chat which goes like whether it's valued in Sri Lanka. That's more or less the focus of what Kisaru's question is like.
Mm-hmm. I think it's I don't think it's not valued, because getting a PhD from these countries such as US, Canada, and Europe, so these are like not a lot of people get that opportunity. So only few people get that opportunity. So if a person with PhD from these countries come to Sri Lanka, that's I definitely think that they are valued, because not a lot of people get that opportunity to get a PhD. And as you all know, most people who do their PhDs, they don't they actually continue their life in these countries. It's only very few people come back to Sri Lanka. So because of that, I think they're actually valued here in Sri Lanka.
Yes, so that was for the people who come back. For the people who want to stay, there's another question, which is like, how do we obtain the citizenship in Canada?
Well, in Canada, Canada is one of the most popular destinations because it's very easy to obtain permanent residence. So first you have to obtain a permanent residence before you obtain citizenship. So to obtain a permanent residence, actually, there is kind of a point system in Canada. That's how it works in other countries as well. So you have to obtain these points. So if you do a degree program in Canada, that kind of adds a lot of points. So if you do a master's, that adds a certain amount of points, and if you do a PhD, that means that's more points. And then if you have 1 year of working experience in Canada, that kind of covers the required points to obtain a permanent residence. So most of the people who follow a PhD here, after they end their academic work, they work for around 2 or 3 years, and within just like 1 year they could actually apply for PR. And after like I think 2 or 3 years, then you can apply for citizenship. You have to, I think, write an exam. I don't really know in detail about this procedure, but the first step is to actually get the PR. So that's not a very hard thing to get in Canada. And again, this depends on the government. So some governments, they are more favorable towards the PR, and some governments are not. So I think that's the procedure you have to follow.
So we hope that answered your question. Until we get some more questions from our audience, I still have a couple of questions. Okay, now we got one from Manidhu. So Manidhu is asking another one. How many fields that we can choose in physics? Another broad question.
Yes, it's another broad question. So as I mentioned previously, there are a lot of fields when it comes to physics. So one of the popular fields in physics are condensed matter physics. So when it comes to condensed matter, there is experimental condensed matter physics and theoretical condensed matter physics. Then there is astrophysics. Then there is atmospheric physics and astronomy, optics, medical physics. So these are all the popular research fields in physics. So you'll find that many universities have these research areas in their universities. So if you want to get more information about these research fields, what I suggest is that you go for these universities pages. So every university has a different page for their respective department. So if you go for their physics or astronomy department, and if you go under research groups, you will find all the research groups in that respective university. And in those groups, they've given a lot of information about what kind of research they are involved with, and they have a lot of information about the students, the professors, kind of research that they're working on, the papers that they have published. So there are a lot of fields when it comes to physics.
Yes, we are drawing towards the end of this discussion. I have a couple of more questions to ask you. One of them is, in your opinion, what are the qualities that are necessary to become a good physicist?
Well, I think one of the main qualities you should have is a natural curiosity to learn stuff. Amazing things happen around us, and physics is involved in every process around us. So you have to have the natural curiosity to learn about this stuff. And I think you have to be hardworking, and I think you have to improve your skill of self-learning. So that's a very important skill that you should have as a physicist, because when you go later in your career, you will understand you have to do a lot of reading, a lot of research on your own to understand these materials. So if you have done a lot of self-studies, that will really benefit you to understand this stuff. So I think natural curiosity, hardworking, and self-learning, those are very important skills that you should have if you're a physicist. But there are again a lot of other stuff as well. So yeah.
My final question will be, what is your message to the next generation of budding physicists who are coming out of Sri Lanka?
Well, my message would be to, if you want to pursue higher studies, get involved with something that you have genuinely an interest on, because doing a PhD is something that takes a lot of time. So try to choose a research field that you have a lot of interest in. So what we are doing as physicists is like really important stuff. that actually improves our day-to-day life. So it's a great feeling to be part of this huge community. So my message is, to choose a research field that you have genuinely an interest in, and to get involved with projects that actually means a lot to our existence.
It was indeed a wonderful discussion that we had with you, Mr. Vasura Jayaweera, and thank you for spending some time with us.
Thank you very much.
Formally deliver the vote of thanks, I'd like to invite Naduni Eratna, the Assistant Secretary of the Physics Society, to deliver the vote of thanks.
I'm Naduni Eratna, Assistant Secretary of Physics Society, University of Colombo. It's a great privilege and honor to deliver the vote of thanks of this session. So my first and foremost gratitude goes to our keynote speaker, Mr. Vasura Jayaweera, for joining us and sharing your valuable thoughts and experiences with us. Moreover, our heartiest gratitude goes to Professor Balodaya, Senior Treasurer of Physics Society, along with all the lecturers and demonstrators for their valuable guidance. Then I would like to thank Mr. Iran Kavinder, President of Physics Society, along with all the committee members who supported us behind the screen. Eventually, I would like to thank all the participants for joining us, and we suppose you earn a lot from this session. Once again, big thank you for joining us, and thank you very much. Udita?
Thank you, Nadini. And with that, we'd like to wrap up this session with one small reminder that our next physics talk will happen on the 23rd of January, and we'll be joined by a very interesting person. So stay tuned on our social media pages to find out who that is. A small hint, it will be about room temperature superconductivity. So with that, good night. We hope you have a pleasant night ahead. Thank you.